Today is May 22nd, and we'll be covering the most recent cutting edge trends that our threat intelligence team is witnessing in the trenches. My name is Keith Wojcicki, the Global Head of Threat Intelligence. This week, we're going to be joined by Vice President Stephen Green, Vice President Dave Truman, Senior Associate Ryan Hicks, and Associate Principal Mukesh Nagar from our Cyber Threat Intelligence team. Today, we're going to cover the following trends that our team is concentrating on. We're going to talk about increase of open redirects, .zip domains, Geacon activity, HAVOC, AMSI bypass, and Ransomware Roundup. So with that, I'm going to turn it to Ryan.
Thanks, Keith. So yeah, first of all, wanted to really highlight for you our kind of recent increase in detections that, in the use of open redirects for phishing in recent weeks. So open redirects are vulnerabilities that are commonly found on websites that allow attackers to redirect users to external URLs, and this occurs when a website accepts user-supplied input as part of the URL parameter in a redirect link. And this is without any kind of proper validation or sanitization. And this vulnerability can be exploited by an attacker to craft a malicious URL that initially appears legitimate because of the legitimate domain at the start, but then redirects the user to a different and potentially harmful website. And it's by no means really a new tactic. However, as mentioned, this has really been observed recently in phishing attacks. Is something that we wanted to bring up. By crafting a deceptive URL that leverages a trustworthy website, actors are more easily able to sort of socially engineer users into clicking that link, and potentially fool technologies that scan links for malicious content, and that potentially result in victim entering sort of credentials in these sort of credential gathering websites. And the anatomy of the open redirect is shown at the image at the bottom there. And you see the yellow part is the vulnerable section, which allows any user to type a redirect link after the URL parameter. And in a campaign that we observed, threat actors were using open redirect as a part of an email marketing campaign on the Bill O'Reilly website, as one example, which you see on the left there. The URL redirected the victim to a customized phishing page, and that just was designed to capture credentials. And in a subset of these cases, the redirect link has also been seen leveraging services such as Cloudflare, and that hindered or was likely to hinder automated analysis of the link itself. And additionally, we've seen geo-blocking being implemented again to ensure that targets could only connect from certain sort of locations. So a few recommendations here, really education, of course, for users on the risks of open redirects, and just continuing to remain vigilant when clicking any link, which is very similar to a lot of phishing techniques out there. And potentially email security tools, particularly those that implement machine learning, could potentially detect and block these kind of redirect links in emails. So just to go on to my next topic, which is the zip domains, which you may have seen and talked about recently. So Google recently introduced new top-level domains that are available for purchase and registration, and two of these of interest, I guess, was zips.zip and .mov. And zip is the one I'm really focusing on today, as these are shared commonly with sort of file extensions, and this could potentially lead them to being used across social engineering, particularly in phishing. And again, similar to the previous story, this is not necessarily a new technique. However, this new zip domain will likely exploit users' familiarity with zip as a file name. We're sort of all used to seeing zips and clicking on that, opening a zip file. Yeah, really exploiting that kind of trust. And these domains are likely to be used in phishing campaigns by threat actors. And examples have already been seen of domains already hosting credential harvesting content. Just to go through a few examples, sort of hypothetical examples of how these could be used here. So example one, we've got a simple kind of contract.zip in an email, really just embedded within the email itself. Quite a simple, not really any obfuscation there, but just relying on the user to think that they're opening a zip file, and it takes them to domain, potentially automatically downloading a file called contract.zip. So it's giving them what they asked for, really. Example 2 starts to mimic legitimate URLs by using subdomains of the purchased domain. We see here that the legitimate Python zip download at the top in green, and the crafted URL is from a purchased domain, which is the 5embed -amd64.zip. And here, potentially a threat actor would essentially create subdomains of that initial domain to mimic that legitimate domain. Of course, the differences between the two visually is this lack of slashes in this case. And just the final example, a threat actor could take advantage of the user info portion of a URL, and that means anything before an @ symbol is treated as user information and essentially or usually ignored by a browser, where it would take a user straight to the likely malicious domain. And in this particular case, the browser would still accept slashes, so there would be an error. So what the threat actor would have to do is add a few or some of the replace slashes with Unicode versions of slashes. So you see that in the middle line there, they're slightly different. However, they still appear to be slashes. And in the last sort of red line, potentially, if you reduce the @ symbol to a really small font, again, it increases the legitimacy of that URL for a user. It's just worth noting that Firefox actually displays a pop-up when the @ symbol is used, so it appears to kind of mitigate this this kind of attack with the @ symbol. It kind of warns the user before proceeding. And then from the bottom image, you can see that there's a few examples of there's a lot of examples, but here's just a few picked out of zip domains that have already been registered that appear to kind of mimic the phishing lures that we commonly see, such as Windows updates. And really, the recommendations, again, very similar to before, really all about user education in remaining vigilant and keeping users up to date with these kind of latest potential techniques that threat actors could use when particularly within phishing. And with that, I'll hand back to Keith to continue the brief.
Thank you very much, Ryan. Appreciate it. I'm gonna turn it to Mikesh for the Geacon activity. Mikesh.
Thank you, Keith. So with Geacon, it's the use of Cobalt Strike, a red teaming and attack simulation tool, has predominantly been observed on Windows platforms. However, there has been a notable shift as Go implementation of Cobalt Strike called Geacon has been emerging, targeting mainly macOS devices. A report from Sentinel-1 identified several Geacon payloads on VirusTotal, some of which indicated genuine malicious attacks rather than red team operations and tactics. Geacon is a project that initially appeared on GitHub over 4 years ago, offering a Go-based implementation on Cobalt Strike beacons. It wasn't until recently that Sentinel-1, as well as ourselves, observed some Geacon being deployed against macOS targets. Analysis of the payload on VirusTotal suggested that the popularity of 2 Geacon forks developed by a developer known as Z3Ratu1 has contributed a large amount to this shift. These forks being Geacon_plus and Geacon_pro. Both gained attention and were added to the 404 Starlink project, a public repository of open source red team and penetration tools. One of the Geacon payloads was ended in resume_20230320.app, was submitted to VirusTotal back in April 5th. This applet employs a compiled run-only Apple script to connect to a remote C2 command and control server and download a Geacon payload. The Geacon binary is compiled for both Apple Silicon as well as the Intel architectures, retrieved an unsigned payload from the IP address. Before initiating the beacon activity, the user is presented with a 2-page decoy document, a PDF displaying a resume for someone named Zoo. The Geacon binary also contains various functionalities for tasks such as network communication, encryption and decryption, as well as being able to exfiltrate data and download additional payloads. The C2 for both the first and second stage IP IP addresses were associated with other malicious samples targeting mainly Windows machines that we observed. The second Geacon payload that was observed was on VirusTotal in April 11th. In this case, the payload is embedded with a Trojan posting as a secure link application for secure remote support. The Trojan has a built-in automated workflow and lacks code signing and targets only Intel devices. Looking at the info.plist file, it indicated that it was developed on a macOS Ventura 13.1 device, but also supports older versions of macOS from OS X 10.9 Maverick and onwards. A lot of this tactic requires users to grant access to the device's cameras, microphones, administrator's privilege, as well as protected data such as contacts, photos, reminders, emails. This sort of stuff is normally governed by TCC. The main executable of the application is the Geacon payload derived from the private Geacon_pro project. Overall, the emergence of Geacon demonstrates a shift in threat actors' tactics, expanding the usage of Cobalt Strike to target macOS devices. And understanding these characteristics and IOCs associated with Geacon can not only help us as security researchers and teams, but also try and identify a way of mitigating potential threats. Our recommendations for this is to ensure we practice the least privilege, which is limiting user privileges to minimize the impact of potential compromises, as well as enabling inbuilt system protections, these being gatekeeper and transparency, consent, and control privacy frameworks, as well as implementing either EDR or NGAV, so endpoint detection response, and next generation antivirus solutions would also help detect non-standard activities taking place on the device. With that, I'll pass back over to Keith.
Thanks, Mukesh. I really do appreciate that. So Dave is going to talk about HAVOC AMSI bypass. So Dave.
Thank you. The open source HAVOC framework has added a hardware breakpoint engine to its 0.6 release. The hardware breakpoint engine is designed to bypass the anti-malware scan interface and event tracing by using debug registers, debug breakpoints, and debug exception handlers to hide the parameters to function calls that a security product might find suspicious. This is on top of HAVOC's already existing indirect system calls feature, which allows the framework to bypass DLL hooks that EDR software uses. By bypassing AMSI, event tracing, and DLL hooking, HAVOC has circumvented the three key components used by security tools to detect malicious activity. Research performed by Kroll's detection engineering team indicates that HAVOC and Sliver, a similar tool, are very good at hiding malicious activity from multiple different EDR platforms. Whilst HAVOC is relatively new and does not have the online following of, say, Metasploit or Cobalt Strike, it will likely grow in popularity due to the increasing EDR install base. Its open source nature means that anyone can use the tool or anyone can incorporate code into their own malware. However, it also means that security vendors could use the tool for writing improvements to their own products in order to detect these bypasses. The best mitigations currently for these type of EDR bypassing tools is using defense in depth. Timely patching, particularly of internet-facing services, robust spam and phishing filters, and phishing awareness training can help stop malware entering the environment in the first place. Common phishing execution chain detections can often stop the download of a second stage. Application allow listing and grey listing can help stop delivered malware from running. And finally, a network IDS can help to detect suspicious connections made when a host has been infected with malware. None of these methods are guaranteed to be successful, so having multiple mechanisms in place remains the best approach. And with that, I'm going to pass back to Keith.
Hey, Dave, really appreciate it. And to wrap everything up, we're going to pass it over to Steve for the ransomware roundup. Steve?
Hello, everyone. Next slide, please. Thank you very much. So we're seeing a bit of a rise of ransomware groups using HAVOC source code. Nearly a dozen in the last 2 years have been using the HAVOC source code to actually create their own ransomware strains. With around 10 were found from the last kind of half of last year. So it seems to be quite a quick adoption of HAVOC source code to build out their own ransomware. The reasons for doing this, obviously, it gets them out on the market really quickly. Means that people can develop their own ransomware really fast and then start selling it to people on the dark web. One of the newer groups that's been discovered is called the RA group, and they've been active since April 2022, targeting organizations in US and South Korea within the manufacturing, wealth management and insurance, and also the pharmaceutical industry. They use a double extortion model like everybody else, threatening to leak exfiltrated data if someone doesn't pay. But crucially, what's different with this group is they actually demand within 3 days. There's normally a bit of flex with other ransomware groups, and this time can vary, but RA groups seem to be very specific with the 3-day timeline. And they also, once the victim's data is put on the leak site, they will then basically sell that on, so people can buy that. So it's like a double kind of revenue stream for the RA group. Next slide, please. And then following on really from people using the HAVOC source code, one of the key reasons for using that is because it can actually target ESXi servers, and there's a massive rise in the ransomware groups trying to target these areas, obviously for actually getting up the VMs and causing more kind of problems for their victims by actually encrypting these machines. And obviously some of the reasons for that is there's no software really that uses like as a antivirus product, and also there's a bunch of ESXi vulnerabilities as well that can be exploited. And as I've mentioned, HAVOC is one of the first groups to actually target ESXi, but we're seeing a bunch of other groups. Alpha just released the Sphinx variant, which also has this capability, and then a bunch of other ransomware groups such as Batbast and Lockbit, and those on that list can also do this as well. And the new group that's just been identified, known as Michael Kors, not sure why they've chosen that name, obviously big fashion brand. They're also started targeting Linux and ESXi machines as of April this year as well. And that is it. Thank you very much.
Thank you very much. And we really appreciate everyone attending today. A big thank you to taking the time out to tune in to Kroll's weekly threat intelligence briefing. We hope you found this session informative. Do enjoy the rest of the week and make sure you tune in for next week. Thank you.